Hi everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be talking about radioactive decay and half-lives for GCSE physics. So if that interests you, feel free to like the video, share it with someone else, and please do subscribe if you haven't already done so. And thank you so much for your support. I really do appreciate it. So let's talk about it. Radioactive decay, well, it's a really random process, and I have made a previous video about radiation on my channel here on YouTube. So I will link it for you in the card section and also at the end of this video too. Radioactive decay, because it's such a random process, scientists can't actually determine when each of the nuclei in the substance will decay, but they can use statistical methods to kind of determine when half of the unstable nuclei will decay, and this is what they call the half-life. So we're going to be calculating half-life in this video, and that's what you need to know for your GCSEs. So let's get into it. So when we actually try to determine the half-life of a substance, we actually have to take regular data points and plot it on a graph to kind of determine the half-life of those radioactive substances. And this can take a really long time to do, but also it's quite a dangerous process. And to make sure that the person is protected when gathering this data, gathering this information, they'll actually use a specific device to measure the amount of decay or radiation that's being emitted. And this is called a Geiger counter. This is actually a really useful particular device because it can tell us how much radiation is being emitted, and this is measured in becquerels or BQ. And as you can see on the graph here, the radiation that's being emitted, of course, starts to reduce as time goes on. And this makes sense because as the nuclei decay at a random time, we won't get a nice linear line. We actually will get kind of a gradual decrease, as you can see from this sloped curve. Now we can do some fancy maths, and actually if we know the half-life, the average half-life, using stats to do this, by the way, if we can do that, if we can figure out the half-life of a substance, we can actually predict when that nuclear radiation will decay further. And we can kind of understand when there will be an emission of radioactive substances and when to know of this potential hazard. And we will talk about hazards with radiation in a future video as well. So let's have a look at some of the maths involved and how you need to know this maths for your exam in terms of half-lives. So in the exam, they like to ask you questions where you have to calculate how long it will take for a substance to decay to a certain mass if you're given the half-life, or you're given the information of how long it will take for half of that particular substance to decay. So this is the example we have. It says uranium has a half-life of 700 million years. If a sample contains 300 grams of uranium, it will take 700 million years for the sample to be halved by 150 grams. So that's how long it would take to half that amount of substance there. The question is, how long would it take for uranium to decay to 75 grams? And based on this information, if we know it's taken 700 million years for the sample to halve from 300 grams to 150 grams, if we half 150, we get to 75. And that's important because it means it's going to take another 700 million years to decay to that 75 grams. So if we start off with 300 grams, how long will it take to decay to 75 grams? Well, it's actually going to take 1400 million years, which is incredibly long period of time, but that would be the answer there. Let's do another one. So we have carbon. It has a half-life of 5,730 years. If a sample contains 50 grams of carbon, it will take 5,730 years to decay to half, so 25 grams. How long will it take for carbon to decay to 6.25 grams? Well, if you look at the difference in numbers, you can see that actually we've gone from 50 grams at the beginning and now we're at 6.25 grams. How long has it taken to get to that point? Well, we've actually divided it by 4. We've halved it 4 times. So what we've done 50, divided by 2 is 25, divide that by 2 again, and that will give us 12.5. You divide 12.5 again, that gives us 6.25. So we've divided it and divided it and divided it. We've halved it and halved it and halved it. So what we need to do is we need to do that amount of halving. So 4 times we've done that, and we need to times that by the 5,730. So if we do 5,730, we times that by 4, we would get an answer of 22,920 years for that amount of carbon to decay by that much in terms of mass. So here's a question for yourself. Please do have a go. Let me know in the comments. And of course, the answer will be in the description box below. The question says radium-244 has a half-life of 3.5 years. So that means it will take radium-244, we have 100 grams of it, it will take 3.5 years for it to decay to 50 grams. How long would it take radium-244 to decay to 25 grams? By the way, the 244 at the end of radium is just talking about the mass number. So it's just talking about the neutrons and the protons that are in that radium nucleus. But yeah, please do comment down below. I'd love to hear what your thoughts are on this one. And that's it from me today. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, feel free to give it a thumbs up, share it with someone else, and please do subscribe if you haven't already. And if you already have done those things, thank you so much for your support. I'm really grateful for everyone who has joined this community. It's lovely to have you here. So please do enjoy the videos that I've linked at the end of this one if you're still looking for more revision. And I do have my social medias as well. Everything is at the GCSE Science Teacher. I post on TikTok and also on Instagram, different content and just bite-sized bits of revision for biology, chemistry, and physics. If you do have any video requests or any revision support or questions for GCSE Sciences, feel free to pop those in the comments section below and I'll get back to you at some point. Thank you so much for your support and thank you so much for your time. Have a great day and I'll catch you in the next one. Bye.